Welcome back, Calc students. Okay, we are right in our second part of this tutorial, and we're going over the derivative of inverse trigonometric functions. We did talk about the Pythagorean identity and the other two that are associated with the Pythagorean identity. We did review the inverse trig sine, the inverse sine function. We also did the inverse tangent, and now we're going to take a look at the inverse secant. Just like before, this is the derivative of inverse secant. This is the derivative, which is a little bit bigger and a little more complex, I guess, versus the other two. It is 1 divided by the absolute value of your u times the square root of u squared minus 1 and times du dx. Now, the u and the du dx is all with the chain rule. So if it's not just an x, you have to apply the chain rule, and thus that's why it's du dx at the end. Okay, so the proof of this, I will quickly just run through this. You don't have to memorize the proof, but I think it's always good and valid to take a look at why it is what it is. Again, I'm going to very similarly solve for x like the other two examples. I'm going to take the derivative of secant y, which is going to be secant y tangent y dy dx equals 1. Solving for y prime, we get 1 over secant y times tangent y. So using some of our algebra, secant y, that's going to be right here. Now tangent y, and this is where I'm going to use Pythagorean identity and go back and solve for tangent, which is going to be secant y squared, oops, I forgot my square root, minus 1, so squeeze the square root in there. Okay, good. And then I'm going to replace, looks like I have sine y, that is our x, so I'll go back and replace this as 1 over, what do I have? This is x times the square root of x squared minus 1. Okay, so then the big thing is, where did they come up with these absolute value? Right here we place absolute value, and that is because the graph of the inverse secant, if you look at the graph, the derivative is always increasing, therefore the slope is always positive. That's why we're going to put the absolute value on that x. There's no need to put the absolute value in here because it is being squared and then square rooted. So that's good. So that's all this. So again, this is the derivative of secant. Here is the example. Y prime, inverse secant of 5x to the fourth. Again, this is just something you're going to have to memorize. It's going to be 1 over, our inside is 5x to the fourth, square root, the u, or the inside, square it, minus 1 times the derivative of the inside, which is 20x to the third. Okay, I'm going to go ahead and simplify a little bit here. This is going to be big fraction bar 20x cubed. The absolute value of x to the fourth, well, that is going to be positive. Anything to the even power is going to be positive, so I can drop the absolute value. I can go ahead and square this x to the, or 5x to the fourth, which is going to be 25x to the 8 minus 1. I can simplify to make this a 4 on top, x on the bottom, square root 25x to the 8th minus 1. I'm going to stop there. You can simplify the inside, the square root of 25 minus, or 25x to the 8th minus 1. But I'm going to stop. You can do that, but that's good enough for this class and what we're doing for this year, and I'm happy with that. There are the other 3 inverse trig functions. And the first 3 are pretty big. You have your fractions. You got to know when it's going to be u squared minus 1, or if it's going to be u squared plus 1, or is it going to be 1 minus u squared. So all those things you're going to have to memorize. Now there's 3 more. Fortunately, they are going to be the exact same thing as the inverse sine, but this is inverse cosine, the exact same thing, but with a negative sign. Inverse cotangent is going to be the exact same thing as inverse tangent, but with a negative sign. And finally, the inverse cosecant is the exact same thing as secant, but with a negative sign. So anything with the, again, the C, is going to be the opposite. So they're the exact, but the opposite. I did want to talk a little bit about the new graph. Well, maybe the new graphing calculators can do this, but I know with the 84s, you cannot. I did mention in the tutorial that you could graph, or the graph of the inverse secant x, and there's not a button on the TI calculator to do that. This is actually the same thing, and how they came up with that, or how you got that inverse cosine of 1 over x, the same thing as inverse secant x, is basically, I'm just going to go ahead and do the same thing as we did before. I'm going to multiply both sides by secant y, or secant, to get secant y equal to x. I'm going to rewrite secant y as 1 over cosine y equal to x. I'm going to multiply by cosine y, and I'm going to divide by x, the old switcheroo. I'm going to get 1 over x equals cosine y. And now I'm going to take the inverse of both sides because I want to solve for y. So the inverse of both sides would leave me with inverse cosine 1 over x. So that is the same thing. These two are the same. So if you wanted to graph this in the calculator, you have to replace it. You have to put this in for it. And there's the other ones right here as well. Okay, I'm going to stop this video here. I'm going to pick up for probably in the next section, which is going to be the derivative of logs and exponents. You'll have an assignment. If you have any questions, please feel free to email.